So this is our project for Dhruv and me, Vincent. So we decided to calculate the maximum deflection caused by a certain given wind on the math building. So this is not to scale, but we assume the width to be equal to 80 feet and the length equal to 120 feet. So we first drew the free body diagram representing the distributed load caused by the wind on the as shown on the XY plane for the free body diagram. So the first step next was to calculate the force of the wind, which is calculated by the drag coefficient for tall buildings, which is equal to 2 times the density times the velocity squared and the area of the exposed cross-section. So we came up with 44,236 pounds. Then we tried to find the distributed load by dividing this by the length of the exposed area. And we found 368.64 pound per foot. The next step was to lay out this equation showing the maximum deflection and to find every missing component. So the Young's modulus for brick on average was found to be 2.65 GPa, and the second moment of inertia in our situation would be equal to 1.152 times 10 to the 7th foot to the 4th. So then we just had to plug everything back in and we found the deflection. This tells us a little bit more about how very little the deflection will be caused from the wind and how much wind the building can actually sustain.